Okay, so let us continue from where we left off. The lecture will last another not more than 10 minutes, I believe, for the first part. So that should not be too much of a burden. The most fundamental type of machine instruction is to move data around, right? And if you think it's very simple, we want to compute something, so we have to move the value, maybe from main memory to register, and then compute, and then move back, and so on. So this is the most variety of instruction is to do the data movement. Okay. The example given here is one of the very big machine. This type of machine we used to call we call big ion. Okay, right. This is IBM 390. Okay, let's see what does it have. We notice that the first one, the top one is getting the data from somewhere inside the processor, and then the bottom part is putting the value from inside the processor to the storage. Okay, so we can just getting the whole number, right? 32-bit, or just half of it, 16-bit. Okay, and we also can do special 32-bit. Okay, from floating point, this is floating point, because the full floating point is 64-bit. That's why we call the short and long is 64-bit. So you can see the most variety. This is also available now in modern CPU as well. Okay, just that this slide uses a very historical instruction set to illustrate. And similarly to, similarly for the storing the data from processor to the memory. All right, it is. Now we're talking about the arithmetic. Arithmetic. We have two different kind of arithmetic. One is the integer, okay, and the second is a floating point. Okay. Let's see the actual instruction. And the another group which related to arithmetic is a logic. Okay. And you probably have learned that from logic design already. So this is also available as instruction in processor as well, to do AND, to do OR, to do exclusive OR, for example. Right. The other thing that has been used to move the bit around, we have the logical shift and rotate. Okay. This will be meaningful if we are doing a low-level arithmetic. Why? If you shift every bit to the right, you actually drop one bit, and then actually it's similarly to divided by 2. Okay, and vice versa. If you shift to the left, it's a multiply by 2. And if you do bit rotation, mostly you want to inspect the individual bit. Okay, and this kind of bit twiddling have two main area of application. One is to actually build the arithmetic operation. If you have a small machine that say you have 8-bit, you want to do a 16-bit integer operation, then you have to manipulate the bit. The second area is to do security, or a kind of encryption. Encryption is very much dealing with pattern. Let's move again. Okay. Right. This is show what happened when you do a kind of bit manipulation. Let's see, logical right shift by 3 bit. So all very difficult to see, right? So the last 3 bit, 110 will be shifting out, right? So the remaining is 10100. So when it shifts by 3 bit, it becomes like this. Okay. You probably almost never encounter this kind of operation in high-level language. But if you want to do encryption, like do advanced encryption encoding, then you will encounter this kind of operation as well. Well, input output, there are variety of approach to get the data from devices. You can name the device, right? You have the special, like we call this, mostly we call the port, isolate program IO, we call some port, right? Memory map program IO is mean you designate some special location, like location 5000 to become your number to access your devices, okay? And DMA is mean direct memory access. Some devices have a big buffer to transfer data. So you designate you think of that devices as a block of memory, and then you issue the instruction to do direct memory access, in which processor do delegate the task of getting data from memory to some special unit. When you communicate between the processor and your graphic card, it actually performed through direct memory access. Okay, that's the most popular example. Okay, and if your machine resided maybe in the server farm, mostly they have their own special processor to perform I/O. This is required high throughput I/O. Okay. System control is a kind of specific to some special need. Okay, right. And to perform this kind of control, you need because of security reason. That means we need special kind of instruction to protect some information inside the processor. It become a norm today, right? Just like on your mobile phone, you probably have to think about, let's say we use fingerprint to unlock the phone, and we don't want our fingerprint data to be retrieved by someone we don't know. So where this data should be stored, maybe we can store it on some kind of service in the cloud. But if I worry that somebody might get access illegally into that information, so I may prefer to store that kind of information on my cell phone, right? And the only one who can access to that information should have some what we call protocol to give the access. So we call those kind of protocol require special instruction to do system control. Right? This is mostly to do with the security purpose. We will not really practice this kind of instruction at all at this stage. Transfer of control type of instruction is actually the jump. Right? If you want to do the loop, then instruction have to repeat. So we can repeat the operation by using the jump instruction. This is illustrate the branch instruction. Okay, like we branch to here, and it is branch to here, or this one branch back. This is mostly, and we will later find it in our lecture, to be a kind of while loop, okay, or for loop, like this. This is mostly if then else, so conditionally it jump over a block of code. We will skip the function call, and we will examine this instruction again when we do assembly language programming next week, because I think this is too early to really get into the detail of this instruction, right? All right, to give you a summary, this is the instruction available in Intel. So many, right? So it have data movement, arithmetic logic control, and there's also high-level language support that's to do with the function call, and many flag control. But for our example, we will use very simple one. And then this is more of a system control, so protection, okay, and cache management. You probably will not see it at all when you program in high-level language. So this type of instruction. Okay, this we will leave for next week, call and return instruction. And this is a kind of different kind of result from logical operation, right? It either if you add some number and the result may have the carry bit. And if you want to check if the parity, this is to do with the encoding of the information. And also we have the auxiliary carry, okay? If you compare two value and it is equal, then a zero flag will be turned on. And you can also know the result is negative or positive by seeing the sign flag. These flags store in special register inside the processor, and we can access, or we can get the value of this kind of flag through special through the instruction, okay, and also overflow. Right? It is used by the person who built library for arithmetic. You can see there's so many, right, operations that can be tested and affecting this arithmetic flag. Okay. And as we mentioned, the Intel also have the media extension. We will not get into the detail, all right? And it has this kind of media instruction extension. Mostly media instruction is to perform operation on many bits at once. Okay. So it's faster. So at the end, in this morning lecture, we talk about machine instruction. Okay, it's a characteristic, the type of operand, and we give very brief example from Intel and ARM type of operation. Let us stop the lecture here, and I